Ever wondered how your phone connects to the internet or how your microwave heats up your food? We live in a world where technology is intertwined with our everyday lives. But have you ever paused to ponder about the invisible forces that make these tech gadgets function? That's right, we're talking about electromagnetic waves. These waves are the silent enablers behind many of our daily conveniences. So, how do these waves work? What roles do they play in our day-to-day lives? Let's unravel the mystery of electromagnetic waves and their applications. Electromagnetic waves, part of the electromagnetic spectrum, are pervasive in our daily lives. But what exactly are these waves? Well, let's dive in and unravel this mystery. Electromagnetic waves are essentially forms of energy. These waves are capable of traveling through space at an incredible speed, the speed of light to be precise. Imagine this, they zip through space at a speed of about 186,000 miles per second. That's nearly 7.5 times around the Earth in just 1 second. These waves are distinguished by two primary characteristics: wavelength and frequency. The wavelength refers to the distance between one wave and the next, while the frequency is the number of waves that pass a point in a given period of time. Now, imagine a vast sea with waves of various sizes. Some waves are tall and far apart, others are small and close together. The same applies to electromagnetic waves. Those with long wavelengths have low frequencies, like the gentle, rolling waves in our sea analogy. Conversely, waves with short wavelengths have high frequencies, akin to the choppy, rapid waves. Each type of electromagnetic wave, from radio waves to gamma rays, has a unique wavelength and frequency. And this is not just an interesting bit of science trivia. These unique characteristics make each type of wave suitable for different applications, influencing everything from how we communicate to how we perceive the world around us. Each type of electromagnetic wave has a unique wavelength and frequency, making it suitable for different applications. Let's kick off with the longest wavelength, the radio waves. Now, radio waves are a type of electromagnetic wave that, as the name implies, are most commonly used in radio communication. They are also the longest waves in the electromagnetic spectrum, with wavelengths ranging from about 1 millimeter to 100 kilometers. But radio waves aren't just for your car's FM or AM radio. They are used in a myriad of ways in our daily lives. For example, they're the reason your television receives signals for your favorite shows. They also enable Wi-Fi and Bluetooth connections, allowing your devices to communicate wirelessly. Radio waves are even used in radar systems to detect the speed and location of objects like planes and ships. And that's just scratching the surface of the vast applications of radio waves. So, every time you tune into your favorite radio station or connect your phone to Wi-Fi, you are using radio waves. Next in line are microwaves, which are shorter in wavelength than radio waves. Microwaves fall right between radio waves and infrared waves in the electromagnetic spectrum, with wavelengths ranging from 1 millimeter to 30 centimeters. Now, why should we care about microwaves? Well, they have a multitude of applications that make our lives easier. One of the most common uses is in microwave ovens. Here, microwaves are produced by a device called a magnetron. These waves are absorbed by water, fats, and sugars in the food, causing them to vibrate and generate heat, which cooks the food. Microwaves also play a crucial role in radar technology. Radars emit microwaves that bounce off objects and return to the radar. The time it takes for the wave to return gives us the distance to the object, a technique used in weather forecasting and air traffic control. Your microwave oven, thus, uses microwaves to heat your food evenly and quickly. Moving ahead, we reach infrared waves. Nestled between microwave and visible light on the electromagnetic spectrum, these waves are a bit of a superstar in our daily lives. But what exactly are they? Infrared waves are electromagnetic waves with wavelengths longer than those of red light, hence the name infrared, meaning below red. Now let's talk about their roles. Ever wonder how your TV remote works from across the room? It's all thanks to infrared waves. When you press a button, the remote sends out infrared waves that your TV picks up and responds to. Pretty neat, huh? But that's not all. Infrared waves are also used in thermal imaging cameras. These cameras detect the infrared radiation emitted by all objects with a temperature above absolute zero and convert it into an image we can see. This technology is particularly useful in night vision goggles and firefighting equipment. So, the next time you switch channels using your remote, remember you are using infrared waves. Now let's talk about the waves we can actually see, visible light. This is the part of the electromagnetic spectrum that our eyes interpret as color. At one end of the spectrum we have red light with longer wavelengths, and at the other end we have violet light with shorter wavelengths. And nestled in between, we find the rest of the rainbow. Visible light is a workhorse performing several crucial tasks. It's the reason we can see the world around us. When light hits an object, it's either absorbed, reflected, or transmitted, and it's these interactions that create the vibrant hues we see every day. But visible light isn't just about sight, it's also an essential tool in technology. It's used in fiber optic cables where it carries information at high speeds from one point to another, revolutionizing our communication systems. Visible light indeed makes our world colorful and bright. Lastly, let's explore ultraviolet rays, X-rays, and gamma rays. These are the most energetic and potentially dangerous types of electromagnetic waves, but they also have incredibly beneficial applications. Starting with ultraviolet or UV rays, these are a type of electromagnetic radiation that resides just beyond the violet end of the visible light spectrum. These rays are known for their ability to cause sunburns, but did you know they're also used in sterilization? Ultraviolet germicidal irradiation is a disinfection method that uses short-wavelength UV rays to kill or inactivate microorganisms. It's used in a variety of environments, from hospitals and laboratories to water and air purification systems. Moving on to X-rays, these are a form of electromagnetic radiation with a wavelength ranging from about 10 billionths to 10 trillionths of a meter. X-rays are most commonly known for their use in medical imaging. They allow us to see inside the human body without making a single incision, making it possible to diagnose and treat a vast array of health conditions. From broken bones to pneumonia, X-rays have revolutionized the field of medicine. Lastly, we have gamma rays. These have the shortest wavelength and the highest energy of any wave in the electromagnetic spectrum. They're produced by the hottest and most energetic objects in the universe, like supernova explosions and regions around black holes. Here on Earth, we use gamma rays in medicine, specifically in the treatment of cancer. Gamma knife radiosurgery, for instance, uses concentrated gamma rays to treat small to medium-sized lesions, usually in the brain. These waves, while having significant applications, need to be handled with care due to their potential harmful effects. Without the proper precautions, exposure to these types of radiation can lead to serious health issues like skin cancer, radiation sickness, and even death. So while we marvel at their power and utility, we must also respect their potential for harm. So we've journeyed through the electromagnetic spectrum, from radio waves to gamma rays. Isn't it fascinating how these invisible waves are everywhere, shaping how we experience and interact with the world? Let's take a moment to reflect on what we've learned. We started with radio waves, those long, lazy waves that carry our favorite tunes and breaking news across miles of open space. They are also integral to our communication systems, allowing us to send and receive signals from everywhere, whether it's from a space probe on Mars to a GPS satellite orbiting Earth. Next, we explored microwaves, the shorter, more energetic siblings of radio waves. They're the unseen chefs in our kitchens, heating our food by exciting water molecules. But their culinary skills aren't their only trick. They're also the champions of radar technology and telecommunications, bouncing off objects to help us navigate the world and stay connected. Then we delved into infrared waves, the invisible heat we feel from the sun or a warm fire. These waves are the silent whisperers of thermal imaging, helping firefighters see through smoke and rescuers find lost hikers. They also bring your television remote to life and allow security systems to detect intruders. Our journey continued with visible light, the only part of the spectrum we can see. It's the artist behind the world's colors, the navigator of photosynthesis, and the catalyst for our sight. Finally, we ventured into the high-energy realm of ultraviolet, X-rays, and gamma rays. These waves can be both powerful and perilous, used in everything from sterilizing medical equipment and detecting bone fractures, to studying distant galaxies and even treating cancer. Our world is awash with these invisible waves, each with unique properties and applications. They're silently at work, enabling technology, driving natural processes, and shaping our daily lives in ways we may not even realize. Next time you use your phone or microwave, remember the invisible electromagnetic waves that make it all possible.